How do isobaric processes make hot air balloons rise? Imagine a hot air balloon gently floating up into the sky, carried by invisible forces. Have you ever wondered what makes that happen? Well, it all comes down to a special kind of thermodynamic change called an isobaric process. An isobaric process is when the pressure stays the same while the temperature and volume of a gas change. In a hot air balloon, the air inside is heated at nearly constant atmospheric pressure, which causes it to expand and take up more space. This expansion is the key to making the balloon rise. When the burner heats the air inside, the temperature increases. Because the pressure remains equal to the outside air pressure, the hot air expands and its volume grows larger. Think of it like blowing up a balloon. As you add more air, it gets bigger. In the case of the hot air balloon, the hot air inside becomes less dense than the cooler air outside. Density is how much mass fits into a given volume. When the hot air expands at the same pressure, it spreads out more, so it becomes lighter per unit of space. This difference in density creates a buoyant force, which is an upward push from the surrounding cooler air. The lighter hot air inside the balloon pushes against the denser outside air, causing the balloon to lift off the ground. During this process, the hot air does work on the balloon's fabric as it pushes outward while expanding. This work is equal to the pressure times the change in volume. So, heating the air at constant pressure makes it expand, decreases its density, and creates enough buoyant force to lift the balloon. This is a perfect example of how an isobaric process works in real life. It shows how heating a gas at constant pressure can lead to expansion and movement, which in turn makes the balloon rise. Understanding this process helps us see how thermodynamics directly influences everyday phenomena like hot air balloons floating in the sky.